Hey geometry students, so we learned all about triangle proofs this week, and so this is problem number 17 from worksheet 9.4. Alright, so first off, this one says that AE bisects BD. So AE is this line right here, and it's bisecting this line BD. So that's kind of like telling us that this is a midpoint for it. It's cutting it in half. So that tells us that BC and CD are two equal segments. So let's mark them that they are. All right. Another thing that we can notice by looking at this drawing is that DCE and ACB, those two angles right there, are vertical angles. So that's something we're probably going to be using at some point in this proof. The other thing we can notice is that it tells us that AB and DE are parallel to each other. So if we were to extend those lines for a moment, and then also look at extending that line there as the transversal, we can notice that these two angles right here are alternate interior angles. So that's going to be something important for us. Okay, so let's go ahead and start this proof. So we got to state our given first. AE bisects BD. And we also have our other given that AB is parallel to DE. Okay, so we've got our two givens. So if we look at this, we've got BC and CD are congruent to each other. And if we remember back to a few minutes ago, we talked about AE bisecting BD. So they're congruent just because of the definition of a bisector. So that's going to be definition of bisector. Okay. So then we also have ACB and DCB being congruent to each other. That's actually supposed to say DCE. Whoops. Okay. So those were our vertical angles. And vertical angles are congruent to each other. So that's going to be our reason for number 4. Vertical angles are congruent. Okay. So then step 5 says that we're supposed to use alternate interior. That's where the angles that we just marked come in. So we have EDC and ABC. So we should have angle EDC congruent to angle ABC because they're alternate interior. The last step is whatever we were trying to prove. So we have triangle ABC congruent to triangle EDC. And our last reason is going to be one of our 4 triangle congruence postulates. So if we look at this one here, we've got 2 angles, and we have the side in between them. So that's going to be angle, side, angle. So ASA. And there we go, all done with number 17.